Rosalind Franklin never saw the photograph that made her famous. In January 1953, a colleague slid it across a desk to a rival scientist without asking her. That single image, known simply as Photo 51, held the answer to one of biology's greatest puzzles, the shape of DNA. Within weeks, 2 other men would build a model from her evidence and step toward a Nobel Prize. She would spend the rest of her short life not knowing how much of her work had left the room without her. Franklin was working at King's College London using a technique called X-ray crystallography. She fired X-rays at strands of DNA fiber and captured how the beams scattered onto film. The patterns looked like blurred crosses and smudges to an untrained eye. To Franklin, trained in physical chemistry at Cambridge, they were a code. She could calculate, from the angles and spacing of those smudges, the actual physical dimensions of the molecule inside a human cell. She had arrived at King's in January 1951, brought in specifically for her expertise. The lab's director, John Randall, had promised her that DNA research would be her own project. But another scientist at King's, Maurice Wilkins, believed the same project already belonged to him. He had been photographing DNA fibers before Franklin arrived. And when she showed up with her own equipment and her own plans, he assumed she was there to assist him, not to lead her own work. The confusion was never fully resolved. It hardened into something colder, 2 scientists in the same corridor, barely speaking, each convinced the DNA problem was rightfully theirs. Franklin was not an easy person to dismiss. Colleagues described her as precise, demanding, and unwilling to guess at conclusions her data could not yet support. In an era when women in British science were routinely underestimated, she insisted on being taken seriously as a researcher rather than as an assistant to male colleagues. That insistence read to some as difficult. To others, it was simply the standard any careful scientist should hold. By the spring of 1952, Franklin had refined her X-ray technique enough to produce startlingly clear images. She discovered that DNA fibers existed in 2 distinct forms, depending on how much moisture was in the air around them, and she carefully separated her research to study each form on its own terms. This kind of caution mattered. It meant her results, when she published them, would hold up. One image from that period stood out. Franklin and her research student, Raymond Gosling, captured it on May 6, 1952, and catalogued it simply as Photo 51. It showed the B form of DNA, the wet, biologically active form, and the pattern was almost hypnotic in its clarity, a black X of dark spots stretched vertically down the film. To someone who understood crystallography, that X practically screamed one word, helix. Franklin recognized the shape. But she was not ready to publish a model. She wanted more measurements, more precision, more certainty before she made a public claim about something as significant as the structure of the molecule that carries genetic inheritance. That patience, so central to her scientific character, would soon become the very thing that cost her recognition. 200 miles away, at Cambridge University, 2 other scientists were racing toward the same answer without nearly enough data of their own. James Watson, a young American biologist, and Francis Crick, a British physicist turned biologist, were building physical models of DNA using rods, clamps, and cardboard cutouts of molecular bases. They were brilliant at theory. They were short on the hard experimental evidence Franklin's lab produced daily. In January 1953, Wilkins showed Watson Photo 51. He did this without Franklin's knowledge or permission. Watson later wrote that the moment he saw the image, his mouth fell open and his pulse began to race. Because the pattern immediately confirmed a helical structure to him. He carried what he had seen back to Crick in Cambridge. Around the same time, a separate piece of Franklin's work reached the 2 men through another channel. Max Perutz, a senior scientist on the committee that oversaw King's College research, shared an internal report Franklin had written for the Medical Research Council. That report contained her calculations, including precise measurements of the DNA molecule's dimensions. Franklin had not intended this document for Watson and Crick. It reached them anyway. This is the moment worth sitting with. Two scientists, working independently and largely on theoretical modeling, suddenly had access to the two most important pieces of experimental evidence in the entire field, both originating from Rosalind Franklin's careful, unpublished work. Neither piece came to them through Franklin's own choice. If you're the kind of person who follows the twists behind history's biggest discoveries, you might already sense that this story is really about who gets credit for an idea and who gets left out of the telling. Stay with it, because the story only grows more complicated from here. Watson and Crick moved fast. Within weeks, using Franklin's data alongside their own model building, they constructed a wooden and metal model of DNA as a double helix, two strands twisted around each other, connected by paired chemical bases, like a twisted ladder. On February 28, 1953, Crick reportedly announced in a Cambridge pub that they had discovered the secret of life. Their paper appeared in the journal Nature on April 25, 1953, describing the double helix structure that would reshape biology for the rest of the 20th century. Franklin's own paper appeared in the very same issue of Nature, alongside a separate paper from Wilkins. Her data was there, in print, presented almost as supporting evidence for a conclusion that Watson and Crick had already announced. Readers at the time had no way of knowing that her photograph and her calculations had substantially shaped the model in the lead article. The order of the papers and the framing around them made her contribution look secondary. It was not. Franklin herself never publicly complained about how her data had been used, whether she fully understood, before her death, exactly how much of her unpublished work had reached Watson and Crick remains genuinely unclear. Some historians argue she suspected little. Others point to her later, friendly working relationship with Crick as evidence she made her peace with the outcome, or simply chose not to dwell on it. The honest answer is that we don't know what she privately felt about the use of Photo 51. Because she left no clear written record of it. What we do know is what happened to her career next. Frustrated by the ongoing tension at King's College, Franklin had already arranged, before the DNA paper was even published, to leave for Birkbeck College, also in London. There, under scientist J.D. Benol, she shifted her X-ray crystallography skills toward a new subject, the structure of viruses, including the tobacco mosaic virus and, later, the polio virus. This was not a step backward. It was some of the most productive and original work of her career, conducted largely on her own terms, in a lab where she was finally the one directing the research. While Franklin built a new body of work at Birkbeck, her health was quietly beginning to fail. In the fall of 1956, she noticed swelling and pain in her abdomen. Doctors diagnosed ovarian cancer, likely linked to prolonged occupational exposure to X-radiation, the very tool that had made her scientific breakthroughs possible. She kept working through repeated surgeries and rounds of treatment, publishing papers even during periods of remission, refusing to let illness define the years she had left. Rosalind Franklin died on April 16, 1958, at 37 years old. She never lived to see the full scientific and cultural weight of the discovery she had helped make possible. In 1962, the Nobel Prize in Physiology or Medicine was awarded to James Watson, Francis Crick, and Maurice Wilkins for the discovery of the molecular structure of DNA. Nobel rules do not allow posthumous nominations, so Franklin, already 4 years dead, was never eligible for consideration, regardless of what role the committee might otherwise have assigned her. Whether she would have shared the prize had she lived is a question historians still debate. Since the Nobel Committee's private deliberations from that era remain only partially documented. For decades afterward, the popular account of the DNA discovery centered almost entirely on Watson and Crick's brilliance, with Franklin appearing, if she appeared at all, if a minor supporting figure, sometimes described in dismissive terms in Watson's own 1968 memoir about the discovery. That book faced significant criticism, including from Crick and Wilkins themselves, for its portrayal of Franklin. It took years of work by historians of science, along with Franklin's own former colleagues and friends, to piece together a fuller picture, that her photograph and her calculations were not background details in someone else's triumph, but foundational evidence without which the double helix model might have taken much longer to emerge. But look different altogether. This kind of historical correction matters beyond one scientist's reputation. It changes how we think about scientific credit itself, about whose careful, unglamorous measurements get remembered, and whose get folded quietly into someone else's celebrated leap of insight. If a story like this makes you want to look closer at the hidden figures behind famous discoveries, that instinct is worth following. Because history keeps more of these stories than most people realize. Today, Rosalind Franklin's contribution is far more widely recognized than it was in her lifetime. Universities, research buildings, and even a Mars rover built by the European Space Agency now carry her name. Photo 51 itself is preserved and displayed as one of the most consequential single images in the history of science, a pattern of dark smudges that, to a trained eye, spelled out the shape of life's own instructions. But recognition, however well-earned, cannot undo what happened in 1953. It cannot give Franklin back the choice of when and how to share her own data, or the chance to stand at that Cambridge pub when Crick made his announcement, or the possibility of a Nobel medal she never had the years left to receive. The photograph that once traveled without her permission now stands, quite deliberately, beside her name. It took the rest of the scientific world decades to catch up to a truth her data had already proven, that the woman behind photo 51 was never a supporting character in this story. She was the one who saw the answer first. If stories like this pull you in, the past is full of people whose work quietly shaped the world before anyone gave them proper credit. Keep looking for them. There's usually more to the picture than the version we were first told. And that's often where the real story begins.